Welcome back, grade 10 scientists. We are moving on to the second part of our Lewis dot diagram lessons. In this lesson, we are going to learn how to use Lewis dot diagrams to draw molecular compounds. So in the last lesson, if you missed it, go back and check it out. We looked at ionic compounds first. Now we are looking at that third method of gaining a full outer shell, which is to share electrons. So Lewis diagrams are very useful for this type of bonding as well. As you can see below, if you've already been looking at the screen, it's really quick, very helpful, okay? You've got hydrogen. Hydrogen on our Lewis diagram is just H with one electron dot. And then fluorine wants to react with hydrogen. Well, you've got fluorine with 1, 2, 3, 4, 5, 6, 7 because it's in group 17. You literally just need to draw them right next to each other and place their electrons into a bonding pair. That's what it's called. We'll get there, okay? So we have a bonding pair. These are also just going to stay in place. And now look, if I put a circle around fluorine, fluorine is very happy. If I put a circle around hydrogen, well, hydrogen's full shell is just 2 electrons because it only has that first shell, right? So they're both very happy. We almost turned it into a kind of Venn diagram in a way. You can also use this method. You can do a line here if you prefer. That also just represents that pair of electrons that's shared by the atoms. So why don't we try a couple examples here? Why don't you draw the Lewis diagrams? We did this exact same example using Bohr diagrams, and it actually probably took a while. You'll see now how quickly we can do these examples. So if you want to pause and try on your own, you can do that. And I will pause and I will, when you come back, there will be some Lewis dot diagrams for molecular compounds here. Okay, so welcome back. You'll notice that I now have a couple drawn out. These are both finished, and I'm gonna overlay it with a different color to just kind of show you what's going on here, okay? So this right here, these are our hydrogen atoms, and they're both contributing their single outer shell electron to this compound, right? And what's happening is I'm placing them next to the single electrons that are looking for pairs, for bonding pairs, from the oxygen atom. So I'm going to just do one full example with you together. Again, this is from the hydrogen. Oh, that's not a great drawing, but that's okay. And there you go. Okay, so we get it. We have the general idea here. Now let's do one together here. We'll do CH4. This is actually its chemical name. We'll go by the name methane. That's its commonly known name, CH4. So we'll start with carbon and we'll draw it. And carbon has 1, 2, 3, 4 outer shell electrons. And we'll place hydrogens. There's 4 hydrogens. That's what this 4 means, is that there's 4 hydrogens all around it because we know that hydrogen has 1 outer shell electron, and those outer shell electrons that it's going to contribute are just going to form bonding pairs right here with the electrons from the carbon. So there you have it. There we go. We've got, and again, I'm just going to use one more color here, and I'm just going to show you every single element here is happy. Carbon is happy. 1, 2, 3, 4, 5, 6, 7, 8 outer shell electrons. Hydrogen is happy. It has 2. This hydrogen is happy. It has 2. This hydrogen is happy because it has 2, and this hydrogen is happy because it has 2 outer shell electrons. So every single atom involved in this compound is happy, and that is why methane exists. So you can use Lewis diagrams to explain why some of the non-metals elements exist as something we call diatomic molecules. A diatomic molecule is a pair of atoms of the same element that are joined by covalent bonds. Diatomic molecules only exist on their own in that state. Okay? Now, the reason why they exist in that state, and this is what I outline here, diatomic molecules or diatomic elements form this way because the 2-atom molecule will satisfy the atoms or the elements want to have a full shell. So it will make them more stable than they would be if they were just existing individually. In fact, like I said, they don't exist individually. Take a look at, well, I'll include one example that you might have heard before. I don't know if you are familiar with O2, but O2 is kind of the fancy science term for oxygen. It's also a very popular company in Europe, if you've heard of it before. They sponsor a lot of things. It's a cell phone company and tech company. So anyways, oxygen, O2. Oxygen only exists in pairs of two when we breathe it in, when it's in the air. Now, that doesn't necessarily mean that oxygen, there's two parts oxygen if we have H2O. That is completely different because it's using those two parts hydrogen to be having a full outer shell. But when it is on its own, it only exists as a diatomic molecule. Let's take a look at another one. Fluorine gas. Fluorine only exists as F2 because they join together. The two fluorine atoms will join together and they both have 7 outer shell electrons. So when they join together, they both receive that full outer shell, that full valence shell of 8 electrons. Let's take a look at how that happens. You've got fluorine here, just a fluorine atom. This fluorine atom with 1, 2, I'm going to leave this one open because I'm going to draw the other one over here. 1, 2, 3, 4, 5, 6, 7. Remember, it's in group 17, so it has 7 outer shell electrons. This fluorine atom is not happy. Okay, it is not satisfied because it doesn't. There's my upset face. It does not have a full outer shell. So what it does is it bonds with other fluorine atoms near it. And that's the only way that fluorine actually exists on its own as a gas, because this other fluorine is a perfect match for it. They are a perfect match for each other because they're both looking to achieve full outer shells, and they do that by bonding together. And now they both have full outer shells, right? This fluorine is happy, and this fluorine is happy. These are called diatomic molecules, okay? Now, there's a bunch of diatomic molecules. In fact, there are 1, 2, 3, 4, 5, 6, 7. There's 7 diatomic molecules. Wait, I'm trying to remember them now. Yeah, there's 7. And here they are right here. So 7 is kind of a tough thing to remember. You've got hydrogen, nitrogen, oxygen, chlorine, bromine, and iodine or iodine, however you prefer to pronounce it, and fluorine, like we said. So there's 6 more on top of fluorine. This is the way that I like to remember all of the diatomic molecules. It's a little acronym, and it is, I pronounce it Hofbrinkel. Hofbrinkel. H for hydrogen, O for oxygen, F for fluorine, Br for bromine, I for iodine, N for nitrogen, and Cl for chlorine. Hofbrinkel. It's a weird word, but it's kind of a word that can, if you say it a few times, it'll get stuck in your head. So that'll help you to remember the diatomic molecules. And again, those are the molecules that only exist in groups of 2. That is it for our lesson today. And I believe that is it for our entire first booklet of notes. So let me know if you have any questions. You can comment on the YouTube video. You can send me an email. You can ask me in class. So let me know if you have any comments or questions. But besides that, I hope you guys have a great rest of your day. I hope this helped. I hope this made some sense. And we will talk to you again soon.